Hello everyone, today I came across a really nice geometry problem and I wanted to share it with you. We are given a circle and a triangle drawn inside it, with its sides as shown in the figure. We are asked to find the radius of the circle, capital R. I strongly recommend that you pause the video and try to solve it yourself first. Now there is a beautiful relationship between the radius of a circle and a triangle inscribed inside it. If we call the sides of the triangle A, B, and C, then the radius is equal to the product of the sides divided by 4 times the area of the triangle. Always. Isn't that interesting? Of course, you don't have to memorize such a theorem. First, we are going to prove this theorem, and then we will solve the problem. Let's begin. Let's say that angle C is x degrees. Since this is an exterior angle, the measure of the arc it intercepts is twice that, which means 2x. If I connect point O with points A and B, then angle O is a central angle, so it is equal to the measure of the arc it sees, which is 2x. Now, from point O, I drop a perpendicular to the chord AB. Triangle ABO is isosceles, because 2 of its sides are radii. That means this line bisects angle O into 2 equal parts. At the same time, the chord AB is also divided into 2 equal pieces. Now, let's zoom in a bit so we can see it more clearly. Take a close look at this yellow triangle. AO is a radius, so its length is r units. We have c over 2 opposite angle x. So sine of x equals c over 2 divided by r. If we rearrange, sine of x equals c over 2r. How can we find the area of triangle ABC? Since we know angle C and the lengths of the 2 adjacent sides, we can use the sine formula to get the area. That gives us 1/2 times a times b times sine of x. And instead of sine of x, we can substitute the expression we found earlier. If you simplify this equation, you see that the area of the triangle equals the product of the sides divided by 4 times the radius. If you want to solve for r, you can just switch things around. Yes, in this way we have proved the equation we started with. Great, now let's solve the original problem. Let's clean up the screen a little. We have one more issue. How do we find the area of the triangle? For this, we will use another very useful theorem, Heron's theorem. Let's say the sides of the triangle are A, B, and C units. Then we define a variable s, which is half of the perimeter of the triangle. In that case, the area of the triangle is the square root of s times s minus a, s minus b, and s minus c. This is a very famous theorem and you should definitely know it. Alright, let's bring back the sides of the triangle and plug in the values. S comes out as 3 plus 2 square root of 2. The area then is 2. If you put b's values into the very first equation, you find that r equals 5 square root of 2 over 2. Yes, I think this was quite a nice problem. Do you think there's another way to solve it? I'll be waiting for you in the comments. See you in the next lesson.